So, what is this thermodynamics? It is a branch of physics. It is a branch of physics. It is a branch of physics. It's a branch of physics that deals with the concepts of heat and temperature, concepts of heat and temperature, and their conversions internally into other forms of energy. Other forms of energy. So concepts of heat and temperature and their conversions internally into other forms of energy. That means, you know, this also obeys conservation law of energy. That is, energy neither be created nor be destroyed, it only transforms. So thermodynamics also basically depend upon that conservation law of energy. So before we go to detail of it, we can study the different type of system which is involved in that. Different type of system which is involved. I don't know. So I hope you are able to see this. So this is a thermodynamics. Already I told you. It is a Greek. It is coming. The word. It's for your knowledge. You don't have to copy. It is coming from the word Greek word, which means flow of heat in physical and chemical reaction. So another way of understanding this thermodynamics is it is the flow of heat. It is flow of heat in physical and chemical reactions. And also, it is not only that. Thermodynamics, it is also deals the energy changes in physical and chemical process. It is deals the changes in physical and chemical processes. Now we are moving on to some of the terms which is, you know, what we mainly uses in this particular thing. The first term is surrounding. It is clear. So only for your knowledge only, we are just giving introduction only. Detail we will study in the next class since lack of time. So only some of the terms what we discuss, that is, one is known as surrounding. So actually surrounding, you know, it is the place where some material is placed. Yes, exactly. And it is the remaining portion of the universe excluding the system. So if you define the word surrounding in physics, it is the remaining portion of the universe excluding the system. That means if you are an independent system, apart from you, whatever is in the universe is the surroundings. Okay, if you are in a small, you are sitting in a small part of the room, but excluding you, that is, you are not included. So excluding that much space, how much space you occupy, because you are a matter. So you are a matter which occupies space. So out of that, how much is remaining in entire universe? That is, we can call it surrounding. So your relation, the energy of your body, your system energy, and how it reacts with the various external forces. External forces means torque also can come, rotational motion can come, straight line motion can come, one dimension, two dimension, all these types can come. How this heat and the temperature react with a particular system, and your thermodynamics more appropriate to we can understand more clearly in the behavior of gas than solids and liquids. We can learn by observing the behavior of the gases. So mainly this chapter we are only dealing with the gas. Okay, and the system and surrounding can be separated by real and imaginary boundary. So in order to understand better, we always separate as a I am a system and me and the surrounding. We will separate what with some of the imaginary boundary. That imaginary boundary we call it adiabatic wall, adiabatic wall, and another one we call it as diathermic wall. Okay, we'll come to that point. So whenever we discuss, we separate the system and surrounding in terms of particular imaginary boundary, and that imaginary boundary we call it, one is known as adiabatic wall. Adiabatic wall means it is a insulator. Okay, that is we are insulating the system from other external forces. Adiabatic wall. So imaginary boundary, one is adiabatic wall. Another one we call it as a diathermic wall. So these are the some of the terms we are using. Adiabatic wall and diathermic wall. Diathermic wall means conduction. Conduction, mainly we are talking about heat. Insulator means mainly heat insulators or insulating the system from the from the effect of heat energy. So thermodynamics is that. So adiabatic wall is behave like an insulator from the heat energy. Diathermic wall, it is behave like a conductor. Conductor means suppose you are a system, you are placed in a particular place, but your body can absorb the heat energy, and that imaginary boundary will become a diathermic. Diathermic means it will allow the heat energy to flow from surrounding to the system. So that is diathermic wall. Now we are moving on to the types of the system. How can you, on the basis of this effect of the heat, we can also define a particular systems on the basis. The first system we call it as open system. So types of the system which is dealing with the heat energy. First system is known as open system. So what do you mean by an open system? Mass and energy can be exchanged with the surroundings. Mass and energy means heat energy. It can be exchanged with the surroundings. For example, a cup of tea, you keep it in open space, it gets cooled. So that means cup of tea is exchanging heat energy from there to surroundings. So that is open system. So you can write example, a boiled water kept in open vessel, or a cup of tea open in the air, open in the space, like that. And what is a closed system? Closed system is there is only the exchange of energy. There is only the exchange of energy, no exchange of mass. That means mass and all will not reduce. Cup of tea, you know that if you drink, yeah, the mass changes. But closed system means heat energy can be exchanged, but mass cannot exchange. Okay, so closed system. In a closed system, there is only the exchange of energy with the surroundings, no exchange of mass takes place. For example, if water is placed in a closed metallic vessel or hot tea placed in closed teapot. So since it is in a metallic surface, naturally there is a chances of losing the heat energy, but not the chances of reducing the mass or something. So that is closed system. Next, isolated system. The third type of system is isolated system.
Ma'am,
Yeah, you want to?
example for a closed system.
A water is placed in a closed metallic vessel. Closed metallic vessel. That is closing. We are keeping the heat energy in a flask or something, which is not insulated. Just keeping in a bottle and you are closing and keeping. So naturally, heat energy only transferred from the metallic wall. Since it's a metal, it is a good conductor. So the water which is in that vessel will be transferred to outside. Okay. Next, isolated system. So usually for ideal world, we always think about isolated system, but it is not practicable. You know it. So isolated system is there is no exchange of energy or matter. There is no exchange of energy or matter between the system and surroundings. So that is isolated system. That's most important point. There is no exchange of energy or matter between the system and the surroundings. Example, keeping hot water in a thermos flask. Keeping a hot water in a thermos flask, because you know thermos flask is an insulator which is preventing for losing the energy. Okay. So these are the a picture of all three types of surroundings, how this energy. First one, energy and matter is exchanging. Second one, closed system, only energy is exchanging. And in isolated system, no more exchange. No more exchange. Okay. So I am just now time up. We will meet at 2:30. Okay. So we'll continue with this later.